Okay, so we are going to do an example with Napier's bones or rods. So the idea behind one of these is it's a little thing like this, and we have some number, let's say, I don't know, 4. And if we have 4, in order to make a proper bone or rod, what we do is we first put in 4 times 1, which is 0, 4, and then 4 times 2, and then 4 times 3, 16, 17, 18, 19, 20. We keep going, 24, 28, we're going to run out of room, 32, no, that's perfect, and 36. So, why create such an object? What can you do with it, right? These are the natural questions. Well, let's say we wanted to find, I don't know, 543 times something. Well, if we have these bones already assembled, what we do is we put a 5 bone next to a 4, next to a 3. Unfortunately, on this computer screen, we have to make them. But this is going to be 0, 5, 0, 3. This is going to be 6, 9. And these go up to 9. 10, 15, 20. Okay, so if we want to multiply by 543 by some number, let's say, well, let's start with 1. What I do is I look right here, and I go across, and I get 0, then I get 5 plus 0 from the 5 and the 0 in this little parallelogram, and then I get 4 plus 0, and then I get 3. Of course, that's pretty obvious, 543 times 1. So let's do another example. If I wanted 543 times 2, I look right here, and I get 1, then I get 0 plus 0, which is 0, and I get 8 plus 0, which is 8, and then I get 6, 1086. If I wanted 543 times 3, 4, 5, I look over here, and I get a 2, 7, 1, 5. 2, 7, 1, 5. Now suppose I wanted something like 543 times 25. Well, in order to do that, what I do is I take my 2 results, like this, and I just take, hey, 543 times 20, 543 times 5, and then I can add these up any way I like. To get 13575. And that's an example of Napier's bones.